Hello my dear viewer, welcome to a mathematics lesson, Form 4. The topic which we are going to discuss is differentiation. Differentiation. This topic is about gradient, basically. I know you learned about gradient in Form 1 and also in Form 2. You learned how to find gradient of a straight line. A straight line has an equation in the form y is equal to mx plus c, where m is the gradient. For example, if we have y is equal to 3x plus 7 as our equation, then this 3 is the gradient of this straight line. And I want you to note that for a straight line, the gradient is constant. So if I have drawn the line, let's say this is our Cartesian plane and this is the line, the gradient at any point on this line is constant. It is the same. So if, for example, at this point the gradient is 3, it is 3 also at this another point. At this other point also it will be 3. So at any point on a straight line, the gradient is constant. It does not change. But what about a curve? For example, a quadratic curve, y is equal to x squared plus 3x minus 2. This is a quadratic equation. And you learned about quadratic equations in Form 2 and also in Form 3. So how can we get the gradient of this curve? For a curve like this one, we don't have a constant gradient. We don't have a constant gradient. The gradient keeps on changing. Since it is a curve, let's say this is our curve. So the gradient is not the same throughout. It is not constant. Let's say at this point, let's say A, at another point B, another point C. The gradient at those 3 points are not the same. Remember, gradient is slope. So at this point, the gradient is, the curve is moving down. And the gradient of a curve is the same as gradient of the tangent to the curve at that point. This is a tangent. So look at this tangent. It's a straight line. So the gradient here is equivalent to the gradient of this straight line tangent. And here at B, the gradient is of this curve at point B is the gradient of this other tangent, which is horizontal. So the gradient of horizontal line is 0. This one here, the gradient is most likely negative. And here, the gradient is different again. The gradient is different. Gradient is the same as steepness, how steep the graph is. So how can we get gradient of a curve? That is what basically we are going to learn in this topic. For a curve, let us consider a curve in this format. Y is equal to x power n. N can be 2, can be 3, can be 4. So if you are given a curve with that kind of an equation, then gradient of the curve, we are going to talk now about gradient function. Why? Because it is not a constant. It's a function, gradient function. It will have a variable in it, a variable like x in it, so that gradient function will be used to get gradient of the curve at any point. So the gradient function of this curve is given as the formula n. You drop the power, then multiply that power by x. You drop that power n, multiply the power by x, then raise x to a power which is n minus 1, or reduce the power by 1. Initially the power is n, now it is n minus 1. So basically, or generally, this is how we find the gradient function of a curve which has this form of an equation. For example, I want to give you examples now. Let's say we have a curve y is equal to x squared or x power 2. What will be the gradient function? The gradient function, let us follow that formula. The gradient function is drop the power. We are going to use this formula. You start with the power, drop the power. So start with 2, multiply 2 by x, then raise the power to 2 minus 1. 2 minus 1. Our n is 2, so n minus 1 will be 2 minus 1. If you simplify that, you get 2 times x power 2 minus 1 is x power 1, because 2 minus 1 is 1. So we have 2x raised power 1, but remember x power 1 is just x. X power 1 is the same as x. So the gradient function of y is equal to x power 2 is 2x. If you follow that formula the way it's supposed to be done. That is example 1. Let's look at another example. Y is equal to x power 3. Y is equal to x power 3. Before I go to this, I want to explain what we mean by this. Now, this is the gradient function of this curve. Meaning, that curve, since we said for a curve the gradient keeps on changing. But if you are told to find the gradient of this curve at a particular point on the curve, then you just take the x coordinate of that particular point. Let's say at the point where x is 2. So you replace this x, value of x here as 2. You will have 2 multiplied by 2, 4. At that point where x is 2, the gradient of that curve will be 2 times 2, which is 4. On the curve where x is 3, the gradient will be 2 times 3, 6. You see the gradient is changing. On the curve where x is 5, the gradient will be 2 times 5, which is 10. So we have a different gradient. So the gradient of a curve keeps on changing. And the gradient function is the one which helps you to find the gradient of that curve at a particular point. Because we cannot get a constant gradient for the curve. We can only get what we call gradient function. So this process, before I even go to example 2, this process of finding gradient function is what we call differentiation. The process of finding gradient function is what we call differentiation. So if you are told in mathematics to differentiate, it means find gradient function. As far as this topic is concerned, I am sure you know that differentiate may have other meanings in English. To differentiate may have other meanings. But as far as this topic is concerned, to differentiate means to find gradient function. To differentiate means find gradient function. So let's look at this example 2. Let us differentiate this, or we find gradient function. And the formula I have given you there. So gradient function is drop the power, start with the power, multiply the power by x, that is 3 times x, then raise to power, this x should be raised to power 3 minus 1. That is the formula. Then simplify. We shall have 3x raised to power 2. 3x raised to power 2. Remember 3 minus 1 is 2. Another example, a third example. A third example. Find the gradient function. Find the gradient function of this y is equal to 2x power 5. Y is equal to 2x power 5. Higher. Gradient function is, we are going to use the same formula, drop the power, but now we have a number here before x. So what shall we do? We shall multiply that 5 by 2x. So it will be 5 times 2x. Then the x is raised to power 5 minus 1. So you multiply. First, if you have a number before x, you multiply 5 by that 2. Then multiply by x. Then x is raised to power that n minus 1. In this case, n is 5. So simplify that. You will have 5 times 2 is 10. X raised to power 4. So 10x raised to power 4. Another example. Y is equal to negative a half x raised to power 4. We have a fraction now. What is the gradient function? What is the gradient function? The process is the same. Multiply the power by this number. If there is a number before x, you multiply the power. 4 multiplied by negative a half. Don't forget the negative. So 4 multiplied by negative a half. Then x raised to power 4 minus 1. If you simplify that, you will get 4 times negative a half is negative 2. 4 times negative a half is negative 2. So negative 2x raised to power 4 minus 1 is 3. Negative 2x raised to power 3. So that is how we find gradient function of a curve. That is how we get gradient function. That's how we get the gradient function of a curve. So what you should know is that for a curve, the gradient keeps on changing. The gradient is not constant. Unlike for a straight line. For a straight line, the gradient is constant. The gradient is constant. But for a curve, the gradient is not constant. It keeps on changing, and that is why we look for a gradient function which has a variable in it. This is a curve. So if you draw this, you will get a curve. The gradient function is this. You see, it has an x in it. So it is not a constant. It has a variable in it. So that is all for today. I will stop there, my dear learner. Next time, in our next lesson, we shall learn more about this topic, differentiation. We shall learn more about gradient function. We shall learn more new terms and more about the concept of differentiation. Have a nice time. Bye-bye.